The Arrhenius definition states that an acid is a species that yields H+ ions when dissolved in water. Examples include hydrochloric acid, nitric acid, and sulfuric acid. An Arrhenius base is defined as a species that yields hydroxide ions when dissolved in water. Examples include sodium hydroxide, potassium hydroxide, and calcium hydroxide. The Arrhenius definition is limiting because it applies only to aqueous solutions and limits the bases only to hydroxide. Recall from general chemistry that neutral hydrogen has one proton and one electron. Thus, a hydrogen atom without its electron is simply a proton. We'll refer to H+ as a proton. A Bronsted-Lowry acid is a proton donor. The compound must have a proton to donate, while a Bronsted-Lowry base is a proton acceptor. It must be able to form a bond to a proton. Here are some examples of Bronsted-Lowry acids and bases. All Bronsted-Lowry acids contain a proton, seen here in red, and the net charge may be 0, positive, or negative. All Bronsted-Lowry bases contain a lone pair of electrons or a pi bond. The net charge may be 0 or negative. There are several types of acids. Monoprotic acids contain one acidic proton. Hydrohalic acids are acids where a proton is bonded to a halogen atom. Diprotic acids are composed of two acidic protons. This means that up to 2 protons can be donated under the right conditions. Sulfuric acid is an example of a diprotic acid. As you can imagine, triprotic acids are composed of 3 acidic protons. This means that up to 3 protons can be donated under the right conditions. Phosphoric acid is an example of a triprotic acid. As we'll see shortly, for di- and triprotic acids, protons dissociate in a stepwise manner, or one at a time. Each dissociation requires its own balanced equation and equilibrium constant. Oxyacids are acids where a proton is attached to an oxygen atom. Examples are nitric acid and phosphoric acid. Other acids include organic acids. These contain a carbon backbone, usually a carboxylic group, shown here. Functional groups like this will be discussed in an organic chemistry course. These acids are generally weak in nature and can contain multiple acidic protons. Most of the acidic protons are bonded to the higher electronegative atoms, usually oxygen. Examples include acetic acid and benzoic acid.